In this video, we're going to talk about section 9.4, the second half, dividing rational expressions. And so I went with a wood grain background. The thing about dividing rational expressions is all kind of hinged upon remembering that when you divide two fractions, or really anytime you divide, it's exactly the same as multiplication with the reciprocal. So in essence, what we're talking about is if we have a rational expression, let's just say a over b, and we're dividing that fraction by another rational expression, let's call it c over d, okay, we can change that into multiplying a over b by the reciprocal of the second fraction, d over c. So now you gotta realize something uber important, okay? We only took the second fraction and we did the reciprocal of the second guy, right? And the other thing was changing division into multiplication. So you leave the first fraction alone, but you multiply by the reciprocal. So once that's done, then we just go back into what we did yesterday, and that's multiplying top to top, bottom to bottom. And if we had common factors to cancel, we would. In this case, a and d over b and c are all different, and we'd be done with that. So let's look at some type of examples that you're going to have to perform for me and do in a quiz or a test. So example 1, let's take a look at this guy right here. We have 5x divided by 3x minus 12, and we're going to multiply that by x squared minus 2x, all of that over x squared minus 6x plus 8. Now I think I said divided by, but I didn't put a little division sign, so let's change that. I was supposed to divide here. We're dividing these two rational expressions. So make sure you have a division sign in there. Now what we're going to do is pretty much what we did last time, but as we rewrite things, I'm going to go ahead and factor, because keep in mind, when we end up multiplying these together, we want to cancel common factors. So remember, we keep the first fraction the same. So I'm going to leave 5x alone, but I'm going to go ahead and factor 3x minus 12. There's a GCF of 3 in there I can pull out. So if you divide 3x minus 12 by 3, you get x minus 4, right? Now I'm going to change into multiplication with the reciprocal. So I'm going to put this guy in the top, x squared minus 6x plus 8, and then that guy, which was the numerator, is now my denominator, x squared minus 2x. Now you might be saying to yourself, why didn't we just factor now rather than write all that out? Because now I have to factor it anyway. I'm doing that so I don't confuse you. Feel free to go ahead and while you write that step of multiplying by the reciprocal, you can write the factorization. But I'm going to continue on with that right now. So now I'm going to copy down that first fraction because that's already factored. We have 5x over a 3 times an x minus a 4. Now let's factor this numerator. Now this one's not so bad. The leading coefficient's 1, so I'm just looking for two numbers that multiply to make 8 and add to make negative 6. And I think that's going to be a negative 4 and a negative 2 that multiplies to make 8, and they add to negative 6. In the bottom here, this guy, I think all I can pull out is a GCF of an x, so I'm left with an x times an x minus a 2. Now, let's take a look at what factors we can cancel. I can cancel out this x with this x, so let's knock those out. I can cancel out the x minus 4s, and I can also cancel out these x minus 2s. So at the end of the day, the only factors left standing in this problem is a 5 in the top and a 3 in the bottom. So this reduces really just to 5/3. Let's do another example. Here we go. Example 2. Let's say we have the following: 6x squared plus a 7x, oops, that's not a 7, a 7x minus 3, all of that over 6x squared, and we're going to divide that by the quadratic 2x squared, or yeah, 2x squared plus 3x. So we're going to divide this fraction by the expression 2x squared plus 3x. Now, when you see a fraction divided by just another polynomial, it's going to be helpful to write that other polynomial as a fraction as well, so that when we do the reciprocal, we know what the numerator and denominator will be. So when I rewrite this, let's go ahead and factor the top here. Now I know I'm going to have to find two numbers, because this is a little factor by grouping problem. I have to find two numbers, m and n, that multiply to make the product of the leading coefficient 6 times the -3, that's going to be a -18, and also add at the same time to make a 7. So I think we're looking at what, a positive 9 with a -2. That'll work. So when I rewrite this, it's going to be a 6x squared, then a 9x plus 9x, and then a minus a 2x, and then copy down the -3. That's all going to be over 6x squared. Let's go another step before we finalize this. The GCF here and here, that would be a 6x, oops, not a 6, 6 isn't, or 9 isn't divisible by 6, but I can take out a 3x. If I divide 6x squared by 3x, I get a 2x. If I divide a 9x by 3x, I get just a 3. And out of this pair, I can pull out a -1, and I'm left with a 2x plus 3. Let's just keep on going here. If I factor out the 2x plus 3's, I'm left with 3x minus 1. So let's write that, 3x minus 1. Whew, man, a lot of work just to factor that numerator. And the denominator is 6x squared. So all we did so far was essentially factor that first fraction. Now I'm going to multiply by the reciprocal of that guy. So it's going to be 1 over this. Now, let's factor it right away to just save another step. I think all I can pull out is a GCF of an x. So if I pull out the x, I'm left with a 2x plus 3. And now I'm ready to cancel. I think all I have are 2x minus 3's. There is no factor of x in the numerator, so I think I'm done, guys. I think we have a 3x minus 1 in the top. And in the bottom, if you multiply x to a 6x squared, there's a 6x cubed. And we are finished with that one. Let's do one last example for this section. Call it example 3. In example 3, we're going to do a few things. We're going to multiply and divide a couple of rational expressions. So we have x over x plus 5 times, let's do 3x minus 5. And then we're going to divide all of this by 9x squared minus 25, all of that over x plus 5. So, good news is there's not a whole lot going on here as far as factoring. I can't factor this first fraction, and I can only write this as over 1 here. And I do think there is a little bit to be factored here. So let's rewrite what we have if we factor it. So I have x over x plus 5 times the 3x minus 5, and that's really over 1. And now instead of dividing, I'm going to change that into multiplying by the reciprocal. So that means the x plus 5 is now in the numerator, and I'm going to go ahead, when I rewrite the 9x squared minus 25, I'm going to factor that. I think that's a difference of two perfect squares. A 3x is being squared to make the 9x squared, and a 5 is being squared to get you 25. So I can factor that into 3x plus 5 and a 3x minus 5. Now, I'm going to see if I have any common factors to cancel. If you take a look, I have a 3x minus 5 to cancel with the 3x minus 5. I have an x plus 5 to cancel with the x plus 5. And I think that's it, guys. I think we're left with an x in the top and a 3x plus 5 in the bottom. And that would be the solution to this one. So here's your self-quiz. You have 3 problems, very similar and parallel to the 3 examples that I just went over. I wish you good luck, and I hope that this video helps you out in dividing rational expressions. We'll see you tomorrow.